A cross enters the penalty box, bodies collide, and the ball hits the net. In real time, the human eye processes a blur of movement. During a match between Croatia and Portugal, a late equalizer appeared perfectly legal. Replays were inconclusive, but a suspected micro-touch from Croatia's Igor Matanovic meant the goalscorer was technically offside. To solve these invisible moments, match officials don't look at better cameras. They look at a specialized wireless charging pad. Before every match, the football itself has to be plugged in. This is the 2026 Adidas Trionda. Beneath its 4 polyurethane panels sits a 14-gram inertial measurement unit, turning the ball into an active data node. By embedding a battery-powered sensor inside the ball, the sport moves away from relying on subjective visual estimates to using precise mathematical data to govern the rules of play. Looking inside the Trionda, the chip isn't suspended in the dead center like previous versions. It's side-mounted, embedded directly into a specialized layer within one of the panels. Placing electronics off-center risks creating a heavy side, which would ruin the flight path. To compensate, engineers integrated precise counterweights into the remaining 3 panels, keeping the aerodynamics perfectly balanced. The chip's primary job is to record and transmit its exact state 500 times every single second, a rate known as 500 Hz. With every reading, the system logs the ball's specific acceleration, its rate of spin, and the exact millisecond a player makes contact. A standard broadcast camera captures around 50 or 60 frames per second. The sensor inside the Trionda tracks data nearly 10 times faster, catching microscopic deflections that slip between the frames of a slow-motion replay. The football effectively acts as an objective, independent timekeeper. It tells the exact moment a pass is played or a deflection occurs. But knowing when the ball is touched is only half the equation. The system also needs to know exactly where the players are. Mounted in the roof of each World Cup stadium is a dedicated array of 12 to 16 specialized cameras. They don't broadcast the match. Their sole purpose is optical tracking. This tracking system locks on to 29 distinct skeletal points on every single player, recording body positions 50 times a second. These 2 distinct streams, the ball's sensor and the camera's tracking, feed into the advanced semi-automated offside technology. An artificial intelligence engine merges the feeds, perfectly aligning the precise millisecond of a kick with the exact anatomical location of the attackers and defenders. This graph illustrates exactly how the Croatia match was resolved. The system generated what officials call a heartbeat graphic, a sharp spike in the sensor data, proving physical contact with the cross. By layering the ball's touch data over the stadium's spatial map, the process of calculating an offside line is entirely automated, leaving no room for human estimation. Previously, video assistant referees spent minutes scrubbing through footage to manually draw offside lines on screens. Now, the calculation happens in the background instantly. If an attacker is offside, the system bypasses the review room, triggering an automated audio alert directly to the referee's earpiece. To explain these instantaneous calls to the audience, the system pulls the exact skeletal data used for the decision and generates a highly accurate 3D avatar of the players involved. Those 3D recreations are then broadcast directly to the stadium jumbotrons and television screens globally, providing immediate visual proof of the ruling. The architecture tested here, deploying localized IoT sensors inside active play equipment, creates a verifiable data trail. For the most heavily scrutinized events in the world, a sport that has spent decades debating blurry replays and subjective calls now operates on a foundation of empirical data. The ball itself has the final word.